Okay. We have finished the topic of sport speed studies. Last time we have started with the travel time studies, which are also called as journey time studies. Okay. So we discussed what are the applications of this data, and then we were discussing different techniques to collect travel time data. One of those is test car technique, and depending upon how and where you are using it, it can be again sub-classified into maximum car, average car, or floating car. Okay, and the main problem here is the how many cars you should allow on the highway at one time. Okay, and then we have the license plate method, and then we have some other methods which are different variations of the first two techniques. Okay, we looked at this data, okay, a data sheet from travel time study, and it's a test car method. This one is a test car method which is applied in Bahrain. I got the sheet from someone. Okay, we did this example and this one, and just to remind you that we are not using any new equations. So you may see the examples without any equations, meaning that the equations are same as that we have already used. Okay. Yeah. Okay. So in this example, they are saying that a series of travel time runs are to be made. Okay. A run means one observation of travel time. Okay. One run means one observation of travel time. Okay. So how many runs means how many observations. Okay. So they are asking us to calculate the sample size. The equation for sample size which we have studied for sport speed studies is this one. Okay, and they are saying that they want to have the confidence level of 95%, and they want to be accurate within plus minus 2, plus minus 5, plus minus 10, and the standard deviation should change from 5, 10, and to 15. Okay, so the different values are given. This is the equation. In this equation, what is S? The standard deviation. Okay, so we have three different values of the standard deviation. Okay, what is E? Huh? What is E? Tolerance level. Okay, and we have three different values of the tolerance levels. Okay, another thing which is given is 95%. Now, where do I put 95% in the equation? Where does it go? E and S only, right? So where is this 95%? Why did they give it? Huh? Yes. So where is the effect of the level in the equation? This one, this factor. Okay, this is because of 95%. If it was 99.7%, only this number will change. Clear? Okay. Now since we have multiple values and we have to calculate for each one of them, we did a similar example for spot speed data as well. I'll make a table here. Okay, here I will put the standard deviations, and here I will put the tolerance levels. They are all plus minus, okay, just keep in mind, I will not writing it. Okay, so you have the equation in front of you, just give me the answer. 24. Okay. What? Which one is 15? 15.3. Oh, 4. Huh?
3.84 or 5.4.
The last one?
No,
3.84. Which one? This one? This one? Okay. Which one? This one is 8.6. Zainab Ali. Okay, this one.
this one is 0.96 and the other one is 15.3.
0.96 in the middle.
And that one is 15.
This is 0.96.
No, this one 3.
Come on. Which one is 0.96? This one?
Yes.
0.96.
And the 0.96 should be 15.3.
This one?
Yes, should be 15.3.
15.3. Sure. Which one?
That's it. That's it.
Then the next one is also wrong.
216.
And you were the one. People cannot even copy you from the exam. Huh? 0.96 is also wrong. Which one? 0.96. Who gave me 0.96? People are arguing what goes where. What is this?
534.56.
Which one?
This one, the arrow.
34 point.
56.
Okay, and this one? 10 and 10, 3.84. And this one? 0.96 is wrong. I will come back to it and you will give me the right answer. How much is this?
8.64.
8.64. Okay, and how much is that? Huh? 15?
15.3.
Okay, increases here, here, and it decreases there. Okay. You can see the trend. Okay, it cannot go up and down. Okay, so you see in one column it's increasing, so the next column will also increase, right? Okay. You see one row decreasing, the other row should also be decreasing. Okay, these are checks you should know about. Okay, these are checks you should know about. Okay, something which many of you did in the exam as well, with the peak hour factor question. Okay, your volumes were more than the flow rate, peak flow rate. Peak flow rate is called peak for a reason, maximum flow rate. Your volume cannot be more than that. Okay. Anyways, so when you increase the tolerance level, you need less samples. Okay, because then you are accepting more error, you need less samples. And with more standard deviation, you need more samples. More standard deviation means the data has more variation. Okay, so to cover more variation, I need to collect more samples. Okay, higher error, if you accept higher error, you need less samples. If you have more variation in the data, you need more samples. Clear? Okay. Now, okay, 15.4 and the next value is 3.84. Okay, obviously I cannot do 15.4 and 3.84, right? So instead of 15.4, I'll do what? 15 or 16? If it is 15.4, should I do 15 or 16? 15, 16, 16. Okay, because these are minimum samples, you cannot do less. If you do less than that, then you are either having more error or you are covering more variation or covering less variation. Okay, so these are minimum values. So even if it was 15.1, I'll still do 60. Okay, you cannot go less. And again, something you have to keep in mind for your term projects as well. Okay. We have travel time study data, and this is a summary of 5 runs. Okay, runs means, so 5 runs means 5 observations. Okay, so they already did 5 observations. This is a summary of those 5 observations. Okay, so you have starting point 1 and point 7. In between, they have made measurements at point number 2, 3, 4, 5, all the points. Okay, so individual points are also covered. So that's why we have now sections. The length and the travel time are given for cumulative. Okay, cumulative means from point number 1. Okay, and they are for each section. These 2 values are for each section. Okay, so each value is from the previous point. This value, these 2 points. This value, these 2 points. Clear? Okay. Now what they are asking us to, tabulate and graphical results, present the results of travel time and delay runs, and show the average travel speed and average running speed for each section. Okay. So we have to find out the travel time and what delay is given. Okay, you can just put the same values, no problem. So we have to find out the travel time of each section and then calculate the average running speed and travel speed for each section. Okay. So for that, okay, go here, copy, paste, make it smaller. Okay, let's see. Okay, the first column is for each section. So I have section from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. I go up to 7, right? So, layout, 6 to 7. Okay, they are asking for travel time. Delay is given. Okay, this is delay of each section. Okay, it's given. I'm not making another column for it. Okay, but what they were asking for was a running speed. The running speed will come from running time. Okay, so I make a column for running time. Okay, and then I will calculate travel speed, running speed. Okay, travel time between travel time between point 1 and 2. Okay, it's the value which is given, right? Because this value is between point 1 and 2. Okay, so I just write the value as it is, 2.05. Okay, travel time for the next section is between 2 and 3. Okay, so they are showing in front of point 3 4 minutes 50 seconds. Okay, now first of all, why minutes and seconds? Why not all seconds? Why not all minutes? Okay, it's because of the stopwatch. Okay, the stopwatch shows you reading like this and you just copy it. If you want to do any calculations, you will do it afterwards, not in the field, not while you are driving or noting down the data. Okay, clear? Okay, so in the field, we try to keep the observations as simple as possible. Okay, we just copy it as it is. Okay, or we have to put 10 marks or whatever. Okay, we try to keep it as simple as possible. Anyways, So for minute 50 seconds up to 0.3, right? And I want between 0.2 and 3. Okay? So up to 0.2 is this much. This value is up to 0.2. Okay? And up to 0.3 is 4 minute 50 seconds. So how much between them? Yeah, I do minus, yes. So 4 minute 50 minus 2 minute 0.5. How much is that? 245. Okay, now you can do the next one, Alpha, right? It will be 730 minus 450. How much is that? What is 2.8? 280, very good. Why are you laughing? 2.8, right? Huh? 320? 240? What happened to 80 then? And what happened to 320? Huh? Zoom in. Even if I zoom in, 1 minute will still have 60 seconds. 240, 240. 240, okay. How? What were you saying? 2.8, right? The answer is correct. 2.8, no? Its answer is correct. But 0.8 doesn't mean 80 seconds. 0.8 doesn't mean 80 seconds. Because 1 minute is how many seconds? 60. So 0.8 of 60. Okay? 40. Yes. Okay? How it is here? Okay? Just pay attention because then I will just write down the value. So pay attention for this one. Okay? 730 minus 450, right? 7 minus 4? 3. Okay? So I have 330 minus 50 seconds, right? 330 minus 50 seconds. Okay? So 30 seconds subtract, it will be 3 minutes, and then 20 seconds left, so 240. Got it? No?
Yes.
Sure?
Yeah.
Okay. Clear or not? We are doing what? 730 minus 450, right? We are still confused with the zooming. Just believe me. 730 minus 450. 730 minus 450, right? 7 minus 4 is 3. So I have 330. Okay. And the remaining how many minutes? 50 minutes, right? Oh, sorry. 50 seconds, right? Already subtracted 4, right? So remaining minutes is how many minutes? 50 minutes, right? 330 minutes, 3 minutes, 30 seconds, minus 50 seconds. Okay, so if you subtract 30 seconds, it will be 3 minutes and 20 seconds left. If you subtract 20 seconds, it will be 2 minutes 40 seconds. Okay, clear everybody? Okay, clear. You can do as he did, no problem. Okay, 2.8, no problem. But just keep in mind, 2.8 doesn't mean 2 minutes 80 seconds. 2.8 doesn't mean 2 minutes 80 seconds. Okay, and when you will do 50 seconds minus, it will not be 3 minutes 20 seconds. It will be 2 minutes 40 seconds. Okay, I'm just telling you the things which they did. So if you did it in fractions, okay, so 2.8 means 2 minutes plus 0.8 into 60. Clear? Okay, it will still give you the right answer. Okay, sure. Now ask him that. He's doing this. English for everybody. Yes, clear? Any questions? Okay. Next one, 9, 10 minus 730. 9, 10 minus 730. One, how much? Okay, 1027 minus 910. 117. Come on. Okay, 11:54 minus 9:20, 10:27. Okay. Yeah. Now, what is the difference between running time and travel time? Delay. Okay. So you have travel time of each section minus delay will give you running time of each section. Okay. So first is 2 minutes 5 seconds. Delay is 10 seconds. So 5 seconds subtracted, it will be 2 minutes. Then 5 seconds again. 1 minute 95, right? Okay. There. Okay, then 2 minutes 45 minus 30. 240 minus 25. Okay, next is 140 minus 42. See, if somebody wrote 0.58 in the exam, I will still mark it wrong. Don't tell me, oh, 0.58, I meant 58 seconds. No. 58 seconds, 58 seconds. It's not 0.58. Okay. 117 minus 47. Okay. And what is this? 127 minus 14. Okay. Clear? Any questions? Any questions? No questions. Okay. Now, travel speed means distance upon time, right? Distance upon time. Which distance? The distance which is given. Okay. And which time? The travel time. Because we are talking about travel speed. Okay. We are talking about travel speed. Okay. So I will use travel time. Distance will not change. It's the same distance for travel speed. It's the same distance for running speed. The only thing which is changing is the time. Okay. So I will use the travel time. Okay, clear? Now, distance is also cumulative, right? Distance is also cumulative. So let us put the distance of each section in one column as well, so that it becomes easier for us. Okay. So the first one as it is, right? Because between point 1 and 2. Okay, so 1 mile. All lengths are in miles. Okay, they are already given on the top. I'm not writing it again. Okay. Then the second one from 1 to 3 is 2.25 and 1 to 2 is 1. Okay, so you subtract. Okay, easy? Okay. 3.5 minus 2.25. 4 minus 3.5. 4.25 minus 4. 5 minus 4.25. Okay, now I just need to divide them, and when you are dividing, you have to keep in mind that the time is in minutes and seconds. Okay, you can convert it into seconds in a separate column and so on and so forth. Okay, but we can just directly do it in the equation. Distance upon time, right? Distance is 1. For the first section, distance is 1. The length is 1. Here. Okay. So 1 upon time. Now my time is 2 minutes and 5 seconds. Okay. 2 minutes will be divided by 60. Oh, sorry. 60 plus 5 divided by 2 divided by 60 will convert into what? Hour. Okay. Clear? Divide by 60 to convert minutes to hours. And divide by 3600 to convert seconds to hours. Okay. So instead of putting a different column, we just put in the equation everything. Okay. How much is that? 24. Okay. And what are the units here? What are the units here? 24 is what now? Meters per hour, miles per hour. What is this? Miles per hour. Okay. This is already in miles, and you converted the time to hours. Okay.
It's 28. So,
28.8. Okay. Next. So length is 1.25 and the time is 2 minutes 45 seconds.
27.27.
Everybody agrees? I have to like do it like a code. I must have two witnesses
Yes.
which are same. 27.27?
Yes.
Yes. The length is already given here, cumulative. Okay, I'm calculating for each section. Okay, so I'll just subtract the previous one. This is the length, for example, this one, 2.25. This is cumulative. Cumulative meaning what? It is from point 1 to 3. And I want between these two. Okay, so 1 to 2 is this much. And 1 to 3 is this much. So I'll subtract them, I'll get between 2 and 3. Like this. That term. That term. Same as our. Yes. Next one. 28 point. Okay. Next. 18. Yes. 11.7. Next. 31. Okay. Now what will change here? This is running speed now. Running time. Okay, distance will remain the same. So 1 divided by, I was doing it with this one, now I'll do it with this one. Okay, without the delay. Okay, so same thing, 1 divided by 60 because it's minutes, plus, what is this? 55 divided by 3600 because seconds. 3, okay, next. Thirty-three point three. Same. Yeah.
Same because it's same.
Yeah, same. Yes. The length is same, the time is same. Should be same. Sure. 31. Okay, next.
Yes.
Next. 29. Come on. Huh? Any problem? The picture is clear. Zoom in. If I give a question from this topic, I should put you should give the picture, right? Yes. Then you will solve it. No. Please. It's not finished. If you want to go, please go. Okay. Any problem here? There? Okay. Now, they were asking for average running speed and average travel speed for each section. Average running speed and average travel speed for each section. Okay, did you calculate an average? Is this an average? No? Can I do an average? For each section. For each section. For each section. For each section, how many values it gives? One. How can you do the average? Like you can, I know. But you shouldn't. Okay, yes, you were saying something.
This is the average.
Why? Who told you?
Because it's given for every
We
section.
can do a different sections.
Huh? We can or we cannot?
We can.
No, don't say can. I don't understand what you are saying. Can or cannot? Cannot? Okay. This is the average. This is the average because the travel time which is given is average of 5. So this is already an average. The travel time which is given is already an average of 5. It's written in the question. It is a summary of 5. Okay, summary meaning it's an average of 5. So we don't need to do any other average. It's already an average. Okay. This is the graph between travel time and delay. Okay. Now you can see the delay is the highest in section 4 and 5. Okay. So where the delay is the highest, that is the problematic one. Okay. The travel time is the highest in section 2 and 3. But this is because of its length, not because of a traffic problem. So you can identify the traffic problem if the delay is higher. Got it? Clear? Okay. This is the graph between travel speed and running speed. Okay. You can see in all the cases, travel speed is lower, running speed is higher. Okay. Because travel speed does not, travel speed improves delay, so it's lower, and running speed does not improve delay. So without delay, your speed will be higher, right? Okay. So that's the reason, and this is again a check. When you are calculating these things, you can check. Okay. If there is no delay, the best cases they can be equal. The best cases they can be equal, but the travel speed can never be higher. Okay, so this is a check. Okay, the last part of the question is how many they are going to hire some test vehicles to collect these samples. Okay, each vehicle is available for 5 runs. One run means an observation, right? So each vehicle is available for 5 observations. Okay, each vehicle is available for 5 observations. Okay, so how many vehicles should be hired in this case? So for finding out how many vehicles, I should know how many samples I need, right? How many runs I need. Okay, for that we are going to use the same equation which we have used for the sample size. Okay, earlier in the last question as well, which is this one. Okay, this is my E value. Okay, so E value is given, and the only thing remaining here is the standard deviation. Okay, now for standard deviation we have this data, right? Okay, we need to calculate the standard deviation from the data. Okay, now if you look at the tolerance, the E value is given in miles per hour. Okay, it's given in miles per hour. If they gave me the tolerance in minutes or seconds, then I will use a standard deviation of time. Okay, but if this value is in miles per hour, then this should also be in miles per hour. Okay, so now I have 2 types of speed, travel speed and running speed. Okay, now you can see here that I don't have any frequencies here. These are 5 values. Okay, these are just 5 values. For these 5 values, the standard deviation, the normal equation is x minus x bar square upon n minus 1. The normal equation. If you don't have any frequency, this is the equation we use for the standard deviation. Okay, where capital N is the number of values I have. I have how many values? 6. Okay, so N is 6. Okay, then x bar is the mean of these values. How much is the mean? Which one? For which column? Travel speed. How much? Okay, travel speed mean 24.40. Okay. And the mean for the other one? Your calculator can calculate this directly, by the way, if you know how to do it. Yes.
32.
32?
Yeah.
Standard deviation for travel speed.
How much?
7.7.
Okay. Standard deviation for running speed?
2.5.
Okay. All of them are in miles per hour. Okay. Now, number of values according to travel speed, number of values according to running speed. How much? This is the equation. E is 3. The standard deviation will change for each one of them.
24.5 for travel speed.
24.5 and how much?
2.6.
Okay. Again, in both cases, we will do what? Round up or round down? Round up. Okay. Now the question was how many vehicles should be hired, right? Each vehicle will do 5 runs. In the first case, if you round up, it will become 25, right? 25. Okay. So I need total 25, and one vehicle will do 5 runs. Okay. So how many vehicles? Okay, and the second case only we will do 3, and how many vehicles? 1 vehicle. Clear? Any questions? Okay, thank you.